So in this video, we're going to be talking about 4 different theorems that have to do with triangles. They're not necessarily related to each other, it's just a few just kind of random theorems about triangles. They're mostly common sense, and you already know this one, the Triangle Sum Theorem, but we're going to hit on these other 3 as well. So the first one we've already proved and everything. It's called the Triangle Sum Theorem because it's about the sum of the angles in a triangle. They all add up to 180. You should be pretty familiar with that one at this point. So we can use this to answer some problems. So for example, in this triangle right here, I know it adds up to 180. So if I want to solve for x, I could do 30 plus 90 plus whatever this is, 5x plus 5. All of that added together should equal 180. And then I can use this to solve for x. So 30 plus 90 is 125 plus 5x equals 180. Subtract 125 from both sides. And so 5x equals 55. Divide by 5, and we get 11 for x. If I wanted to actually find the measure of this angle, I could plug in 11. Or another way to do this problem would just be take 180, subtract the 30, so you're down to 150, subtract the 90, so you're down to 60, and then just set this equal to 60. So subtract 5 from both sides, 5x equals 55, divide by 5, and there you go, x equals 11 again. So go ahead and pause the video and try these other 2, and then I'll go over those. Okay, so on this one, you would add up all 3 angles. They should equal 180. So x plus 3x plus x plus 15, all of that should equal 180. So that's 1x plus 3x plus another x, that would be 5x's total plus 15. Subtract 15 from both sides, so 5x equals 165. Then divide by 5, and that is 33, I believe. Okay, so that's x on that one. On this one, again, add them up. They should all equal 180. So x plus 21 plus x plus 61 plus x plus 23 should all equal 180. That's 1, 2, 3 x's. And then 21 plus 61 is 82. 82 plus 23 is 105. Then subtract 105 from both sides. So 3x equals 75. Divide by 3, and we get 25. All right. So the next theorem we're going to talk about has to do with isosceles triangles. Just as a reminder, isosceles triangles have 2 congruent sides, just like this. I kind of remember that because it's got like 2 S's in it, it's got 2 L's in it, it's got, well, no, that's an I, just kidding. I don't know, sauce just kind of sounds like symmetric, I don't know. So in an isosceles triangle, what do you think we might conclude about angles B and C? Do you have any guesses? So it turns out, if you have 2 congruent sides here, you also have 2 congruent angles, which kind of makes sense. This is called the Base Angle Theorem because you could kind of think of these as like a base on this isosceles triangle. Even if it's turned sideways, we would still call, if those 2 were the same, we would still call this the base. And so those 2 angles, or these 2 angles, we call those base angles. And they're always congruent, as long as the triangle is isosceles. So if 2 sides of a triangle are congruent, then the angles opposite them are congruent. Basically, like this side goes with that angle, this side points to that angle, and so these 2 are congruent. Again, we can use this to answer problems. So for example, I'm again trying to solve for x. I don't really know what these are yet. All I'm given is the 136. But if that's 136 and this is a straight line, I know that 180 minus 136 would be 44, because these are supplementary. Then I know that this triangle is supposed to add up to 180. So 180 minus the 44, we're actually back to 136. And so whatever these two angles are, they should be 136. And since these are base angles and I'm on an isosceles triangle, I know that these two are congruent because they're opposite of these congruent sides. So if I want to split up the 136 evenly between the two, I'll just divide 136 in half, and that would be 68. So both this angle is 68 degrees and this angle is 68 degrees. They're congruent. Again, go ahead and pause the video and then try some of these on your own. All right, hopefully you've tried them, and we're gonna go over these. On this one, again, I have an isosceles triangle, meaning the two base angles will be the same. The angles that like these sides kind of point to are the same. This one could be anything. So that's 49. This one's 49. Together, that adds up to 98. And so if I do 180 minus 98, that leaves me with 82 degrees left for angle x. So that's the answer there. On this one, again, it's isosceles. These are congruent, and so I know that these two angles here are equal. So if I want to solve for x, I can just solve this equation for x. So I'm going to subtract 2x from both sides to get the x's over on the same side here, leaving 1x minus 11 equals 11. Then I'll add 11 to both sides to get rid of this. So I get x equals 22. It did say to find all the missing variables, so I'll need to find y as well. If x is 22, I could put that in for x and find what these variables, these angles actually are. So like 2 times 22 plus 11. What is that? That'd be 44, 55. And if this one's 55, this one's also 55 degrees. And so together that's 110, leaving me 70 degrees for this last angle, because 180 minus 55 minus 55 leaves 70. So just divide by 2, and y is 35. That's my other variable there. Okay. On this one, again, sometimes you may not know what to do, and you may just have to play around with it until you can find something that works. I don't know how to jump straight from here to x, but I do know this is isosceles, and if I take 180 minus 62, that leaves me with 118. And that 118 should be split evenly between these two congruent base angles here. So 118 cut in half would be 59 for each of those. Again, I just cut 118 in half to get that. Okay, notice this was isosceles, but also this triangle here is isosceles. So if these are the two congruent sides, then these are also congruent angles. They may not be congruent with these, but they're at least congruent to each other. All right, now what I can do is this right here forms a straight line. So this should be 180. So you can do 180 minus 59, and that is 121. So this angle right here is 121. And now, if I do 180 minus 121, that gets me back to 59, and that 59, so this triangle, if you take 180 minus 121, you get 59 left, and that 59 needs to be split between those two base angles evenly. So divide it in half, and you get 29.5. That's what x is going to be. And this one too. Finally, with base angles, the reverse is true. So on these, you had an isosceles triangle, two congruent sides, meant you had two congruent angles. On this one, if you have two congruent base angles, that also means you have two congruent sides. So basically, 5x minus 11 equals 2x plus 7. This is just extra information, you don't need that. So I'll just solve for x real quick. Subtract 2x from both sides. So 3x minus 11 equals 7. Add 11. So 3x equals 18, divided by 3, and x is 6.